Good morning. In the last class, we have discussed the average number of photon and average number of energy. So first of all, we are going to calculate the total energy emitted from blackbody cavity and total number of photon we have to calculate. How can you calculate the total number of photons particle emitted from the blackbody? So we always remember. First, we calculate total number of photon. It is very essential. Okay, why essential? Why essential? See, if you understand the blackbody phenomenon, it is phenomena related to photon particle. Then you can easily understand the phenomena related to phonon Pacific theory, Debye theory, Einstein theory, because it is related to photon, and that one Einstein Debye theory related to phonon. So both are boson and following the same principle, same rule. And if this all calculation is same to the calculation for phonon. Okay, only you have to mention that it is for phonon. Calculation, mathematical formula, all rule and calculation, everything is same. Average number of phonon is same. Average energy spectral density is same. Everything is same. So it is very essential to calculate number of phonon, total number of photon coming out from the blackbody radiation cavity. So, how can you calculate total number of photon? This is the formula. Number of photon, d and number of particle. It is always into G nu d nu, this density of state, number of microstate available. That's what we have calculated into average number of particle into number density into average number of particle is equal to total number of particle. So we can replace as G nu d nu into this average number equal to Bose-Einstein distribution function, because average number we got equal to 1 by e to the power h nu by kt minus 1. It is equal to e to the power e beta minus 1, and 1 by e to the power alpha plus beta e minus 1. Here this is known as the Bose-Einstein function, Fe. Okay, because in phonon or photon, alpha is always 0. Chemical potential alpha is 0. Chemical potential is 0. So there is just to make similar to the Fermi-Dirac distribution of Bose-Einstein distribution function, I put it alpha here. So you can replace, and you can replace like that Fermi function. Fermi function, you don't confuse Bose-Einstein function. In case of boson, photon or phonon, they are boson, so it will be Bose-Einstein function. Bose-Einstein function, it represents the probability of particle. Okay, index number. It is represent always index number in statistical physics. Fermi-Dirac function or Bose-Einstein function, it is only probability. Probability means number of particles. Simply, I can say that probability Pn E equal to Ni, average number of particles. It is written as this function. Always remember. Okay. This is a probability means the formula is a number of particles occupying in a particular energy level divided by total number of particles. Like head and tail. So why the probability of head or tail is half? Probability equal to total number of event in denominator and favorable event. Favorable means whenever we see the event, either head or tail, we can see either head or tail. So it is 1 divided by total number of event, head plus tail, 2. So it is always half. Similarly, in probability in calculation, total number of particles in denominator equal number of particles in a particular energy level. Okay, energy level E. This function is known as the probability function. If it is boson, then Bose-Einstein function. If it is fermion, then Fermi distribution function. It is known as the distribution function. So this is what I can replace. What is the formula? Okay, formula is that 8 pi v. Why it is 8 pi? Originally it is 4 pi. 2 is multiplied because photon has a 2 state of polarization. That is why it is 8 pi. 8 pi v. Okay, nu square by c cube into this one, e to the power h nu by kt minus 1 d nu. Is it okay? This is the number of particle, total number of particle. D and number of particles, the density of state into Fermi function or average number. Whatever you like. If you multiply average number with density of function, you will get the total number of particles. So now if we integrate total number of particles, how can you get 8 pi v integral nu square d nu e to the power h nu by kt minus 1. Is it okay? Now, so n is equal to 8 pi v c cube integral 0 to infinity nu square d nu e to the power h nu by kt minus 1. Okay. Now I simplify the calculation. If I take h nu by kt equal to x, so d nu equal to kt by h dx. I transform the calculation. 8 pi v c cube 0 to infinity. So it will be how much? Kt h square into x square d nu equal to how much? Kt by h d nu. So dx into by x minus 1. So it will come at 8 pi v c cube into kt by h cube 0 to infinity x into by x minus 1 dx. One thing always remember, whenever we encounter this type of calculation, it will be 0 to infinity x square e to the power x minus 1 dx. Always remember it will give a number. Okay? Always give a number. So no, it will give number, we don't focus on that. Forget about that. It will give number, numerical value 2, 3, 4, 5, something like that. So forget about the calculation. What we can understand? What we can understand n equal to 8 pi v c cube kt is cube into m is constant. Suppose c, a constant value we will get from the integral. We don't need to solve the integral. Okay? No need to reason. No question will be no question asked. Similar question never asked in exam. Okay? No need to find out the numerical value of integral. You just put a constant. Okay? Now what happened? Number of photons proportional to v proportional to t. This formula is very essential. Is often come net, gate, SLET. So it is very easy calculation. How easy I have shown. So number of photon particle emitted from the Blackbody is proportional to volume. If you increase the volume, then number of particle accordingly increases. No need to remember this formula. Okay, you just to remember what is the variable. Variable is v and t. K constant, H constant, C constant, Pi constant. This constant not necessary. Okay, no need to remember all this formula. If you want to remember this formula, solve it and do the integral. You can find out. Only you have to remember some variable and temperature. So proportional to temperature. So often question is like that. If the temperature of the Blackbody radiation is increased 50%, so how many number of photon is increased? Okay, so this is the formula. Cubic proportional to cubic the temperature. I will again show you when I solve the numerical problem. Netgate question paper solve. I will go. Then what I am showing here, how to do calculation easily. That's what I am going to see. And why density of function is so important for calculation. All calculation in statistics, all calculation in condensed matter physics, all calculation in semiconductor. Number of carrier calculation, whole and electron conduction band balance event, this type of calculation. So total energy, how can you calculate? In laser spectroscopy, this is very essential in laser spectroscopy also. Whenever we encounter laser spectroscopy, we are talking about photon. So we have to find out the spectral density. Spectral density means total density. So that is why in number of microstate, understanding of number of microstate or density of state, okay, is very essential. So if you want to du, or you can write du energy. what you have to do? First of all, density of function you have to multiply into what I am told you, into average energy. Okay, I have told you average energy equal to how much? H nu e to the power H nu by kT minus 1. Okay, so it is H nu into function. Is it okay? In some book, that is why it is written as G nu d nu into E into F. It is often, this type of formula often find in semiconductor book. Any semiconductor book, Millman and Halkis or Donald Newman, if you study Donald Newman, you will find energy like this. Okay, E into F, or you can say density of state into average energy. Both are same. Okay. So it is very easy calculation. Z you already know, 8 pi V nu square CQ d nu. It is from this part. Okay. Into this energy into H nu. Okay. E to the power H nu by kT minus 1. This is the formula. Or simply we can write 8 pi V is CQ integral. This is a total energy. Okay, total energy. 0 to infinity nu cube d nu e to the power H nu by kT minus 1. Very easy calculation. No need to bother about it. No need to remember. Just density, average energy. If you forget, you can find out easily within 1 minute. It's not a big issue. So this equal to total energy equal to 8 pi V H CQ integral 0 to infinity nu cube d nu e to the power H nu by kT minus 1. Okay. Now similar to the previous one calculation, you put H nu by kT equal to x. So d nu equal to kT by H dx. You replace it. 8 pi V H CQ 0 to infinity. No need to change the limit, because whenever nu is 0, x is also 0. Whenever nu is infinity, x is also infinity. So upper limit, lower limit of integral will remain same. So it will be how much? kT cube. Okay, x cube kT by H into dx. Is it okay? It will be by x minus 1. So it will be how much? 8 pi V CQ H kT H to the power 4 integral 0 to infinity x cube e to the power x minus 1 dx. See, no need to find out the numerical value of this integral. This is a standard integral. You will get some numerical value, 1, 5, 6, something like that. We don't know. So we are not focusing on that part, integral part, because integral, it does not contain any variable. It will give only numerical value. So I consider it is alpha. Alpha is a constant. Suppose. So what I can understand, the average number of photon, total energy of the photon, 8 pi V is CQ kT 4 and integral, suppose constant. This is a constant from this integral. This constant. Okay. So average energy, total energy proportional to V volume of the cavity and proportional to T to the power 4. In exam, what type of question is like that? Okay, but we can understand only to remember the power. This a variable is temperature and volume. So this, from this calculation we get energy proportional to volume and proportional to T to the power 4. I simplify as a, in question often it is given as a like that. BV T to the power 4. Question in exam is like that. If the energy of a photon or phonon is this one, then what is the specific heat of phonon? Suppose phonon and photon both relations are same. So if this is suppose energy of the phonon in condensed matter physics. What is the pacific heat? It's simply Cv equal to du by dt. So what we will get? 4 bv bv dq. So this Cv proportional to dq. dy pacific heat theory. This is the dy pacific heat at low temperature. You got this formula. Pacific heat at low temperature proportional to Tq. But one thing is always remember, this is the pacific heat of solid in case of phonon only for 3-dimensional. Okay, it is not 2-dimensional formula. This equation pacific heat of phonon is proportional to Tq is only valid for 3-dimensional crystal in case of phonon. Okay, this type of question often asked in the exam. So this, whether it will be T cube or T, it will depend on these percentages. See, suppose it's a question in net gate exam. In a particle, but in question it doesn't mention whether it is phonon or photon. It doesn't mention the particle. Okay, if they mention the particle, type of the particle, we can easily find out. Okay, but if a particle having dispersion relation, E is proportional K to the power 2. This is the dispersion relation. What is the dispersion? I will tell you later. Then what is the pacific heat? Pacific heat at low temperature. Then answer is 1 proportional to Tq. Okay, second one proportional to T3 by 2, third one is proportional to T and T square, which are the correct. So often student give the answer this one. This is the wrong answer. Pacific heat of solid and low. But because this question does not mention whether it is phonon particle. Okay, this pacific heat at Tq formula is valid for phonon only. Phonon is boson. There may be another type of particle which also the boson may not be phonon. So we have to, that is why we write the general formula. Okay, general formula you always remember. In the meantime I am giving energy proportional to, pacific heat proportional to, pacific heat equal to constant. Okay, B is constant. I am not going to write all the formula. T D by S. This is the formula, general formula you always remember. This is the general formula. If you know the general formula, you can find out the pacific heat in 2-dimensional crystal, pacific heat in 1-dimensional crystal, pacific heat 3D crystal. This is suppose 3D crystal. And S is what? Integer value. Okay? And D is the dimension. Suppose in D by theory, the crystal is considered as a 3-dimensional. So dimension it will be 3. But dispersion relation here, S is the integer value which is obtained from power of the K. Dispersion relation S equal to 2. So pacific heat proportional to T3 by 2 is the correct answer. But this is in 3D. Okay. In case of 2D structure, D equal to 2 and S equal to already 2 given here. Then pacific heat proportional to T2 by 2 proportional to E. Okay. This pacific heat is similar to the electronic contribution. Electronic contribution of the pacific heat also proportional to T, irrespective of dimension. This is why you have to focus on the basic and fundamental part. Once you understand the basic and fundamental part, you can easily understand the question given in the net gate exam, and you can easily find out the correct answer. That is why I am telling you. Okay. This is the basic theory. And now I am going to give you the ensemble theory. One of the most ensemble theory. Now I am going to write the mean energy, probability formula. Probability formula. What is the probability formula? Now question comes. Now this is very, very essential as per net gate exam. Okay, what is the probability? Normally why probability is written as PR. Okay, N as a ER. It is written like this in a book. It is nothing but energy index. Okay, probability is total number of particles, and in numerator it is number of particles occupying in a particular energy state. Or in case of coins, total number of probability formula is total event, favorable event divided by total event. So in case of coins, so favorable event when we see we can see either head or tail. So favorable event is 1, but total event head, one tail is tail. So it will be half. Similarly, probability formula is given as, in statistics it is given as I, or you can write also R, because I have written R, e to the power beta e. Okay, it will give total number, because you always remember exponential beta is what, 1 by kt. So coefficient of dimension of beta is electron volt inverse and energy electron volt, so it will be the cancel out. So E, it is e to the power constant, it will give a constant number. Always remember, this will give a only numerical number, numerical value. It does not have any dimension. Always remember. So this is the total number, similar to this, and this is the whatever the energy state. This is the state. Okay, this is the formula. But this formula is valid for non-degenerate system. This for non-degenerate system. So general formula, more generic formula I can write you GR e to the power minus beta e. Okay, GR. This is the formula. GR is the degeneracy factor. How can you understand? A question. Question you carefully read. Question number 1. This question comes in the net exam. A system composed of n particle and each particle have two energy state, 0 and E. Okay, which are non-degenerate? Find the probability at E equal to 0 and E equal to E state. Okay, when beta E tends to very less than 1 or beta E very greater than 1. This is the question comes in the exam, net exam. So what we have to understand, the system composed of n particles. So what is the formula? First of all, we are going to calculate two energy states. Each particle has two energy, E equal to E and E equal to 0. Particles can stay at this energy level and this energy level. Now, what is the question? Find out the probability of particle occupying energy this level and this level. So this is the formula. ER, GR, e to the power minus beta ER, GR, e to the power minus beta ER. So first of all, we are going to calculate this state, P0 state, P0, energy equal to 0 state. Then this is the total summation, because the question tells that the whole system is non-degenerate. Then means degeneracy is 1, GR equal to 1. So it will be, this will be 1, e to the power minus beta into 0. Okay, first step. Next, 1 into e to the power minus beta E state. And which state we are going to calculate? 0 state. 0 state means it will be 1 e to the power beta 0. Okay, this will give equal to 1 plus e to the power minus beta E. Okay, this is the probability of finding particle in energy level E equal to 0. Okay, or you can say and 0 state total. This equal to this. This is a fraction of particle. This is the P0 means probability of finding the particle in energy level is 0. 0 state. Or you can say that this is the fraction of particle occupying energy level, this one. This one. This is suppose 0 state, energy is state. Okay. This is represent P0. This represent P. Okay. This is the formula. And next we are going to calculate. Here. That is why you have to understand the meaning of this question. Second, we are going to calculate probability in each state. Okay. Denominator is remain same because it is already summation. So first one is 1 into e to the power beta 0, beta into 0. Next one 1 into e. This is remain fixed. Denominator is always represent total number of events. So total number of events means total number of energy level available in the system. Only 2. So we are 2 steps. If the system composed of 3 energy level, then there will be 3 terms. Okay. Now we are considering this part in the second stage. So 1 into e to the power beta e. Okay. So it will be e to the power minus beta e 1 plus e to the power beta e. This is the probability of finding the particle at the present time. Now, suppose you want to verify whether your answer is correct or wrong. Then what happens? For total probability of finding particle here and here is must be equal to 1. If you add P1, if you add P0 plus PE equal to how much? If you add this part equal to 1 by 1 plus e to the minus beta e plus e to the minus beta e 1 plus e to the minus beta e equal to how much? Equal to 1. That means your answer is correct. Okay. This is the answer. So now question is that we are getting two probability. P0 is equal to 1 by e to the 1 plus e to the minus beta e, and PE is equal to e to the minus beta e 1 plus e to the minus beta e. Okay. So I can simplify this 1 by 1 plus e to the minus e by kt. I simplify e to the minus beta e by kt 1 plus e to the minus e by kt. So condition 2, when beta is very greater than 1, that means what? Beta means e by kt very greater than 1 means when e is very greater than kt, or you can say this means what? When temperature is very low or tends to 0. This condition and this condition same. Okay, when temperature tends to 0, then if we expand this P0 state, whatever, if T tends to 0, anything divided by 0 means what? Infinity. So this 1 plus infinity means e to the power infinity means this is what? E to the power minus infinity. E to the power minus infinity equal to 1 plus 1 by infinity. So e to the power infinity, any number to the power infinity give will infinity. So 1 by infinity means it will be 0. So e to the power minus infinity, always remember it will be 0. So it will be 1. Okay. And next you see P e to the power minus beta e. Beta means e to the power kt 1 plus e to the power minus e by kt. So what happens when t tends to 0? E to the power infinity. E to the power infinity means e to the power minus infinity is 0. Okay, 1 plus 0 means 0. Okay, and you can verify because in P0 state we are getting one probability, rest of the state must be 0. This is the logic. And we are getting also 0 energy. Probability 0. That means what? What we have understand. But in this question, I am not telling this particular electron. Okay, this particle may be boson. photon on something. What happens when the temperature is tends to 0? Whole particle when T0, when T tends to 0, then P0 equal to 1. P0 means what? N0 divided by N equal to 1. And P state is, I am getting 0 means N E state divided by total number of particles 0 state. So N E state equal to 0. Okay. So N not equal to N. That means you see the consequence. So when temperature 0, all the particles from the excited state fall to the ground state, and this is known as a Bose-Einstein condensation. But this is only for boson particle. But in case of electron, when you consider the system consists of if it is electron, then it will not happen, because according to Pauli principle, no particular energy cannot accommodate more than 2 electrons. But in the case of what happens when temperature tends to 0, or N naught ground state, N naught is the number of particles occupying the ground state equal to total number of particles. That means all of particles occupying fall in the ground state. So total number of particles in upper state is 0. This is one. So case 2. So this way you have to analyze. When temperature is very high, infinity, then probability P0 state is equal to 1 plus 1 e to the power minus e by kt. Okay, and P E state is equal to e to the power minus e by kt. 1 plus e to the power minus e by kt. This is the formula. But T tends to infinity. So T is infinity. E to the power divided, any number divided by infinity tends to what? Any number divided by infinity tends to 0. So it will be 1 plus e to the power 0 equal to half. Okay, and it will be what? E to the power 0, 1 plus e to the power 0. Even no need to evaluate in exam. Once your particular state you are getting energy probability is half, and rest of the energy probability, rest of the state is also become half, because total probability is 1. Okay, this equal to half. What does it mean? This equal to P naught. P naught equal to, I am telling you, N naught divided by N. So N naught divided by N equal to half, equal to 50%. Okay, similarly PE equal to NE divided by NE by N equal to half, equal to 50%. And now question is like that. In the net gate exam, they may not ask the probability. Sometimes they ask the question is like that. So what is the fraction of particle occupying in a particle energy level? So fraction of particle means probability. So P naught is half means N naught divided by N is half, 50%. And P is equal to half, N E by N, N E by N equal to half, 50%. This is the fraction of particle occupying in energy, upper energy level. This is the fraction of particle falling in the ground state. So what happens when we increase the temperature at very high temperature, the equal number of particles distributed to energy level. Okay. That in the meantime, I want to tell you one thing. In laser system, 2-level laser system, we often say that 2-level laser system is not good laser. Why? Because for laser action, the population inversion must be take place in a certain level, in a upper energy level. But in case of 2-level laser system, at high temperature, equal number of population take place. Means upper energy, number of particles in upper energy level and number of particles in lower energy level is same. So population inversion not take place. That is why 2-level laser system is not good laser, because of this condition. At very high temperature, equal population is happen into energy level. That is why it is not a good laser. Okay. This is non-degenerate problem. But a degenerate problem, what type of degenerate problem you may ask? Question is number 2. So you see the difference. You see the difference. A system, same question. A system consisting of 3 energy level. 3 energy with n particle, with n number of particles. Okay, each particle. You can check today NetGate question paper. If you see the question paper, you will find similar question, 1 or 2 question every year, 3 marks. Okay, and it is very easy. Similarly, all statistical questions based on Patria book are very simple and easy. It is only essential to understand the basic, and you have to understand the question very carefully. Each particle can have 3 energy level 0, E, twice C, and E and twice C are fourfold degenerates. Okay, that means a system consisting of n particle. Each particle have 3 energy level 0, E, and twice C. Okay, and energy level E and twice C are fourfold degenerate, but energy level 0 is non-degenerate. So find the probability 0, PE and P twice C respectively. So how can you understand? Now I am teaching the question. So a system of n particle, each particle has 3 energy level, E equal to 0, E equal to E equal to twice. Okay. Now we have to calculate the probability of each step. That means probability of particle occupying energy level this one, energy level this one, energy level this one. Total number of particle n. Out of this total number of particle, how many number of particle occupying energy level this one, and how many energy level this one, how many this one. That's what I'm going to do. Solution. See, we know the formula, probability formula. ZR, it is summation beta ER, okay, and ZR is equal to minus beta ER. Okay, this is the formula. Here is the question because I don't have so many space in the board. So, first one I am going to calculate. This is non-degeneracy, Z0 equal to 1. Okay, this is Z1 equal to 4-fold degenerate. Z2 equal to 4-fold degenerate. 4-fold degenerate means Z equal to 4. Non-degenerate means Z equal to 1. So first I will calculate E0 step. Probability in the first step. This formula. So first one is non-degenerate, e to the power minus beta 0. Okay, plus 4-fold degenerate Z equal to 2 into e to the power minus beta E. Okay. Next one means 4 e to the power minus beta twice E. Is it okay? Now in the numerator, this is the total event. Total event means total number of possible energy level. Total number of microstate available in the system. Total number of microstate available in the system is 3. And now I have to calculate particular favorability. Favorability means I want to calculate probability in 0 state. So that part I have to put in numerator here. So ground state, first 1 into e to the power minus beta 0. It will give equal to 1 plus 4 e to the power minus beta E plus 4 e to the power minus 2 beta E into 1. This is the formula. This is the probability in the step 1. But one thing always remember, denominator will not change. Only numerator will change. P is state. If I calculate, denominator will be same 1 plus 4e beta E plus 4e beta twice beta E. Numerator will be 4 into e to the power minus 4. Where from where you get 4? This is the formula. I am writing it again. GR sum of GR beta ER beta ER. This is the formula. So it will be 4. In case of E, degeneracy is 4. That's why put at 4 beta into E in the second level. And third level, twice E level, numerator will remain same. It will known as a partition function. I will tell you what we mean by partition function in the second class. Today I am not going to tell you. Okay? And next one will be 4 e to the power minus b beta into 2e. This is the probability. This one, this one, this one. Now you can verify your answer is correct or wrong. You add up P0, PE, P2IC. Add this theta. If you get 1, that means your answer is correct. This way you have to solve numerical problem relating to the probability. The rest of the question, what type of question often asked in based on the mean energy formula fluctuation, I will tell in the second class according to the. Once after completing this part, I will go to the numerical solution of NET-GATE exam. So I will solve. This is the basic things you have to understand. If you have any question, you send a SMS or you can call me as to the mobile number. Okay, thank you.